Assalamu alaikum. My name is Muhammad Yasir Hassan and my teammate is Muhammad Uzair, and today we are going to discuss about CPU scheduling. We are going to delve deeper into the topic of process scheduling. Process scheduling is a critical component of operating system design, and it's responsible for the efficient allocation of system resources to various processes. In this presentation, we will discuss the basis of process scheduling, its importance, and the different scheduling algorithms and their implementation. What is process scheduling? Process scheduling is a process of selecting the next process to be executed by the CPU from a queue of processes waiting in the ready queue. When a process is loaded into a memory, it becomes a process, and the operating system assigns a unique identifier to each process to manage it effectively. The process scheduler determines the order in which the process will be executed and allocates CPU time to each process. Why is process scheduling important? Process scheduling is essential in modern operating system because it allows multiple processes to execute concurrently. Without process scheduling, the operating system would execute each process sequentially, which would significantly slow down the system. Process scheduling also ensures that operating systems remain responsive to the user request and that critical response are executed promptly. Primitive and non-primitive scheduling. There are two main types of scheduling algorithms. The first one is primitive scheduling. In this type of scheduling, the CPU can be taken away from a process even if it has not completed its execution. The operating system can interrupt the current process and allocate the CPU to another process with a higher priority. Primitive scheduling ensures that the critical process can be executed immediately and that the system remains responsive. Non-primitive scheduling. In this type of scheduling, the CPU is not taken away from a process until it has completed its execution. Non-primitive scheduling is simple to implement but does not require as much overhead as primitive scheduling. However, it may not be suitable for real-time systems or systems with critical processes that need to be executed immediately. Implementing scheduling algorithms. Now let's talk about how scheduling algorithms are implemented. The process scheduling algorithms is typically implemented into the operating system's kernel. The kernel maintains a list of all processes in the system and their current state, such as ready, waiting, or blocked. When a process requests CPU time, it is added to a ready queue. The scheduler selects a next process from a ready queue and allocates CPU time to it. The process is then executed until it completes or voluntarily yields the CPU. The scheduler algorithms implementation depends on the scheduling algorithm being used. For example, the FCFS algorithm is implemented using a simple queue data structure. When processes are added in the end of the queue and removed from the front, the round-robin algorithm is implemented using a circular queue data structure where each process is assigned a time quantum and is placed back to the queue if it does not complete within that time. Scheduling algorithms. The process scheduling algorithms is responsible for selecting the next process to be executed by the CPU. There are different scheduling algorithms available and each algorithm has its advantages and disadvantages. The first one is first come first served. In this algorithm, the first process that arrives in the ready queue is selected for execution. This algorithm is easy to implement, but it may lead to long waiting times for shorter processes. Shortest Joe first. This algorithm selects the process with the shortest execution time next. It is more efficient than FCFS algorithm and ensures that the processes with the shorter execution times are executed first. However, it can lead to starvation, where a long process never gets executed. Priority-based scheduling. This algorithm assigns a priority level to each process. The higher the priority, the sooner the process gets executed. This algorithm is suitable for the systems with critical processes that need to be executed first. Round-robin scheduling. This algorithm is time-sharing algorithms that assign a fixed time slice to each process. The scheduler assigns each process a time quantum and the process is allowed to run for that amount of time. If the process doesn't finish execution Within the time quantum, it is placed back to the ready queue and then the next process is selected. Multi-level queue scheduling. This algorithms divide the ready queue into the multiple queues, with each queue having its scheduling algorithm. Processes are assigned to the appropriate queue based on their priority, process type, or other criteria.
Assalamu alaikum, I'm Muhammad Uzair. Now I will discussing about the practical working of these algorithms. There are the times that a process taking in their execution. First one is arrival time, the time at which a process enter into its ready queue. Second one is bus time, the time required by a process to get execute on CPU. Third one is the completion time, the time at which a process complete its execution. And turned around time one can find completion minus arrival time. Second last, waiting time. Waiting time we can find turned around time minus bus time. And the last time is required response time, the time at which a process gets CPU first time minus arrival time. This is the example of first come first serve algorithm. There are four processes and the arrival time and bus time is given. We can making with the help of these times Gantt chart. Gantt chart give us the completion time. With the help of completion time, we can find turned around time, and with the help of turned around time, we can find waiting time, and the average waiting time is given. Now looking at SJF, SJF stands for shortest job first. In this algorithm, we can discussing the those processes that have bus time less as compared to others, and process 3 has bus time is 2, and the process 1 has bus time 3, and so on. And you see that process 3 coming firstly and process 1 then, and other processes coming in later, and other execution is same as FCFS. And third scheduling algorithm we are discussing priority scheduling. In this algorithm we are having another column as priority. The process is coming in the based of priority level, and the process 1 we are seeing that process 1 has priority 10, but the little priority is the highest priority, and so on. And process 1 coming first because its priority level is highest, and other processes are coming with the help of priority. Now looking at round robin, it is a preemptive algorithm in which we are having quantum time too. Quantum mean a time at which a process leave its execution and going on ready queue. Now discussing the multiprocessor scheduling. Multiprocessor scheduling can be used when processes are related to one another. Scheduling two or more than two threads at the same time across multiple central processing units is called space sharing. And discussing the real-time scheduling. A real-time scheduling intended to serve real-time application requests. It must be able to process data as it comes in, typically without buffering delays. Processing time requirements, such as including any OS delay, are made in shorter. Then determines the order of real-time task executions, and highest priority process run first. And at last, real-time scheduling is one of the most active areas of research in computer science. And that's all about process scheduling. Thank you for watching.